Okay, Mara's still here. Sorry, Mara. I just. So, well, this is what I'm getting. You know, I just had a drink, like I tell you, but I just like have this kind of thing. Yeah, it's like this is what this is just this is just chocolate, but instead of chocolate, it's funny. It's like a. Sorry, this. It's a bit of creativity. But you know, I just keep this out, but it's still like boiling, so it's like kind of one solution we have in Nigeria. You know, I'm autistic, but you know, this is just a normal standard solution. You know, it doesn't mean it's hard. It just means you have to solve the problem. You know, if it's a hard problem, use hard solutions, but you don't need a hard solution to solve a hard problem. Look, Mara, basically, this is why it matters. But look, let me give you an example. Literally, Mara, I love this kind of solution. Look, it doesn't matter what this is. This is a bowl. You call this a bowl, Mara? It's a big bomb. There's liquid in it. It's gonna be water. Yeah, it's water, but it's what? Chocolate? It's chocolate, Mara. Look, Mara. It's chocolate, but it's chocolate and look, you got this thing in it. But it's used for other things. It's easy to wash. It's easy to wash plates. Look, it doesn't matter. You know, if you can put something in it, you know, you can wash that thing. So that's what NSIGGI really is. It's like a means of communication. Because you know, protocols are means of communication. It doesn't matter what it is. Only can solve your problem. That's how we do it in Nigeria, and that's why I'm making it like this. Because you know, if I don't solve this problem properly, you know, all of people are gonna die. Like, computationally, look, this is like a bowl. A bowl is for something. Use it for something. You can use it for anything, from like cooking to cleaning, for you know. But you can put some. As long as the bowl can hold it, contain it. For example, it doesn't matter what it is. If you can contain it properly, whether it's water or food, what you can use it for that. You know, that's what I'm saying. It doesn't have to be a means of bureaucracy, like talking. That's what NSIGGI matters. Look, this is a program of human rights. This is what I'm cooking with it. Look, that's what I'm saying. You can cook with this pot. Look, but this bowl is contains what? Hot chocolate. Hot chocolate. Yes, hot chocolate and what? Porridge and what? And what? Like this kind of thing. What's the type of porridge? Look, this is a bowl. Same thing. Can you use it for food? You can't use smash this bowl. So this bowl has to be protected. So you use it to cook and clean and stuff like that. It doesn't matter. This bowl can be used for three things. It doesn't matter. But we do that in Nigeria. You know, because what? We share it. We share it, and it's not enough, guys. Look, I'm cooking here. You know, I'm putting a little bit of cooking here. But this thing is like useless to me. But I'm putting it dry here, but it's clean because it doesn't get burnt. It doesn't get burnt. No, because I'm using it. Literally, if this gets burnt, I'll still make another one. And that's what we do in Nigeria. We'll make our own things. You know, if it doesn't work for me, and that's what looks all kind of interesting to you. Basically, I made a water fountain. Most of us like there in Nigeria, look, but I made a water fountain design and so using it because the same thing happens to me. Basically, I had some fountain here. For example, I put this fountain into some liquid, and I put that straw under this thing. You know, because we have to do it. We have to do it. You know, it doesn't matter what's a breakthrough or no. We have to do it, no matter how dangerous it is. You know, someone has to clean the gas pipes. We don't want to do it. The only person clean the gas pipes, or the oil tank, oil tanks. Yes, someone has to. No one, it doesn't matter who cleans it. You know, someone has to do it when you're doing that job. When it's a trade, and that's the kind of thing I hate. They have a use for it, but if you use it incorrectly, you know, if you're already there, use it incorrectly. Because we have all of tools, we have things, we have everything there, you know, everything and nothing. You know, that's what the program is. This kind of egg, it's here. I can eat this egg, but if it's not mine, what? I steal it? I steal it what? I stuff, you know, we get guns, we can kill each other. That's it. This is my, what I was drinking, Mara. I was drinking. I just came back here, I didn't even know I had it here. Like, okay. So, my policy, program will not be conversation. Anything, as a policy, as a very personally, protocols are not means of communication. They're means of everything and anything. Someone says, anything that can mean something, explicitly mean something. We have tomographic implications of policy. So that means we have a tomographic policy system. That must mean everything is everything on them. Everything's interdependent. Interdependency, A to B, you have this halfway between A and B. So nothing is dependence have the same high degree. Basically the base hierarchies are very you know, this is like everything everything was in tomographic resolution. Via the Chinese principle. Keep quiet, Dylan! This man. Keep quiet, Dylan. So basically, the China police is like literally let me think. I wasn't recording anything because I forgot. Anyway, let me start new recording.
Tell him to close the door.
No, I won't forget that now.
Close the door, it's cold.
I don't care, he's shouting me now. You know, don't give shit, he's shouting. Throw him out, okay? Me, no, I don't understand him nothing. I don't give shit. If I understand him, I tell you I understand him, but I don't give shit. I don't want to understand him, you know? I don't care. If I understand him, I lie. Because I understand calculus thing. He understand calculus, you know? I got time, you know? I just do. Keep quiet, Jordan!
Baba.
What I mean, Mina? What I mean, Baba?
Baba, you asking for somebody?
Oh, I don't know, shit. I know be that though.
Oh, simple. It's the most wonderful time, Jordan. Wonderful time.
Well, it doesn't matter what it is, you know. As long as the knife, it doesn't matter if the blades or what you bring a weapon, it doesn't matter what it is. As long as you can get the job done. That's what I'm saying. That's how we do this in Nigeria. I think it gets the job done. It doesn't matter if we're corrupt or not. It just matters if we get ourselves sorted. You know, that's what's always been. You know, if you go back to the ancient days, you know, ancient texts, or ancient Hebrew text, you know, that's when you look in our frame, you know, not Igbo, not like Egypt, all the Greek is banned, you know, because when we write things down, it's like that. We don't. Basically, it's been in a text because we wrote it. You know, it's not like God. It's not like things we wrote. Not like Abraham. Not like all of them things. We do all those book stuff. When we write it down, it works. You know, it works because it's already been in our Hebrew text from our Hebrew origin, from our side of the story. That's what I'm saying. It's like personal. It works for us because you know we wrote it. You know, it doesn't work the other way around. I'm saying that it's a personal. So the kind of thing I'm saying is that let me just sit down, Mara. I'm gonna go. I'm talking to you in a minute. I love talking to women. Blonde doesn't matter who it is. I love blonde. Women are the best. but it doesn't mean I have to suffer for blonde. I could have just like a. Look, I know what Hebrew sugar looks like, but I don't remember a lot. I know what it looks like, but I don't know what it means anymore. I don't know what it means. So that's gonna have a problem. No, because my mom always had a Hebrew Bible. Sorry, I don't know, Hebrew book. A Hebrew book. She mom was Jewish. She didn't care. I don't care about mom. So basically, Mara, roof demographic system. So basically, the foundation of the this man, what's the title? This is the if you want to call me, I don't really feel Mara, I don't really care. Oh, Mara, you can call me, but other people can call me too. OBA in excess. The time, so Mara says she do. Okay, did it. Implicit policies only. Lastly, there's a Australian principle. So the principle is like if everything, this is Australian principle here. So implicit policy, everything is implicit. Because I don't like policies, rigid policies. No static clauses. When you have implicit, everything that's implicit means that you know you declare it ahead of time. But you know you have to define what you want to declare. So it's kind of just types definition. So you hold the space and time. A definition until it resolves of itself. It doesn't rotate flip itself. It just has to be works for everyone. It's trident. It works in access. So it works in alignment. So example, this one rift alignment. It's called alignment. I call it a rift alignment because the lift process or like a gating alignment. Because you get for example, stage this is that we start at the stage. So we already got a contract. ZZZ 001 basically tomographically. E is epsilon. So this is a stage, this is an epsilon, but they don't resolve into anything. So this is ZZZ or Z, this is a parity Z, E, but this EE means epsilon. So this is the one we all share. If something works across all the mediums, we share it, and that's epsilon stage. Is this recorded? I don't know. Yes. E for epsilon, E for epsilon. If I have E for epsilon, you have negative E. I have negative E if you have E. That's negative. That means epsilon state, and then E. We have 1, 1. So this epsilon we share this E, but we share negative and positive. So you have a minus Z, because you know that's basically the Z axis. So X is so basically you have with tomography test where you can test it, which is basically it's imported implicitly, but you have a specific policy defined ahead of time because you have something that's baked into riff files. So you have things the riff test has enforced its own structure into a bubble. So you ecosystem. For example, So I'm 24 right now, guys. I'm 24. This is NSIGGI protocol here, and but look, basically this is the macros that are. This is a ref file, but this is standard ref file. This is a ref file, but this ref file is for what? Ref dot this is called ref file. This is a macro, but this is a macro for all languages. It doesn't matter what language you use. You know, you define what macros here, but the macros are universal. Basically, this macro is only for ref digital downloaders, like no non-digital, or just like a physical download, like USB sticks. So basically, you can download Rift with the Rift any file star the Rift, but you can have the name of a file as a policy that maps to all the wallpapers. You have a metaphor, you have an implicit Rift file. So this is a Rift file, R file. That's R file, but it's a Rift file. But it's not the Rift file. So this one file. Now this is Rift.taml. Now this is system level configuration, or platform level configuration. Doesn't matter what your Windows, Mac level, but you don't know if the target REPL is Python, and you will not run a Python REPL. This is what the system runs is Python. Anything that runs okay, it's a different. Anything the system Rift.taml is the taml equivalent. So this is the master switch. Yeah, system. Yes, so this is the master switch for one ecosystem. This can be Python. Because we know Python, but this is Rift or something, because Rift is really in Rift, it's C. But this is a C Rift file, but it's a master switch. Oh, it's really sorry, Mara. Basically, this is membrane. The membrane just means what? The brain process information. So basically, it means like the thing that's actively been doing the job. This is a membrane. So it's a memory brain, but it's a branch. So it's like a branch. But not a node, because it's basically the main brain. It's not a. It's actually anything that's actually doing the job. It's an edge, but it's an edge of a brain system. So it's a system that expects itself, so it can grow our brushes and grow more nodes. This is like nil, no context assumed. Basically, this is the different come from. This is just a riff of TOML, but this is what Python is usually TOML or PyTOML. That's basically this syntax here is Python default. That's why it's Python native. So this is Python. This if you want to run this, you can run some Rift dot py. Okay, you can use some the standard pack. What's the package name for Python? Package name for Python. This is the dimensional variation lexical, syntactical. Because if this is a Python REPL or Python terminal, you are using Python syntax. So this is a membrane in brackets, in right angle brackets, and this is coherence underscore threshold equals 0.9 form. This is not good enough. This is like what the main target is, the main function target. If it's between 0 and 1, it has to not float. So this is like this is the canonical implicit of what a type. Think of it like a big number, 0 or 1, but the big number between 0 and 1 is arbitrary, because 0 or 1, when you hold one thing, you hold the whole thing, but that whole thing can be in categories. So it can be like a 10 set of class, 10 instances in memory, and 10 instead of something is cluster. But if that's one cluster, that's also one system. One system you run natively, because 1 to 10, it's a number between so there's some 10 classes on one system. So 10 classes that run that define some kind of object, you interact with some interface, and some just 10 objects is fine ahead of time. So look at the problem here. I'm going to down again. I have to get up now. Sorry guys. So basically, this kind of files here are the mandatory files for it. It doesn't. Sorry, my fault. I'm doing some work now. So basically, this piece is back because I don't want to move. The problem is sorry. So basically, this is a TOML file. This is just Python. Because this is a lower package. This would be a lower rocks file. This would be a lower rocks file. Or and package.json or package.json. Or the native ones. So like or Deno. I don't know Deno file. Basically, the canonical default for all the canonical systems. It doesn't matter. It's npm. This is just a TOML example. But you can write Rift in TOML in Python because it's just a Python machine. Basically, this is just written in C. But it should be in C.TOML. But C doesn't have a standard packaging system. That's why it matters. I can package this anyhow I want to package it for one target platform. That's why it matters. You get what I'm saying? So it's going to be no custom. You don't assume anything or chat mode false. Basically, the chat mode is like default rotation nil. So nil means no type, no value, no pointer, just a nil pointer, no context. No, it doesn't hold any context, just holds it's like a yield. Basically you get a void pointer, which is pointed to null, but doesn't hold null in memory, or no this, no type of memory. It only holds its state. So it's still. So very important to tell them. Ta-da.
Is exactly 2.
So basically, it doesn't. This is basically this. This is what I'm saying. So you get this thing here. Oh, I'm just checking. Is this has to stay? Let me just
Times when it crosses a line and when it doesn't cross a line, and I could actually.
So let me get a video camera. I'm gonna get a video camera, like a video stream, camera for the full screen. So I'm saying. You can see it. I can't see either. So basically, let me just read out to you. This is my work. Today, this is like the still definition you made. Mark is reading the still. Basically, it holds no context, no nothing for all the systems, systems. So it works like that. So still just means it has to be. All still does have two branches of access. So it's still because it's actively active. It knows what it's doing. It's not passive. It actively advocates. It's an active system and it's sparse. It's sparse, so it's basically active on sparse or sparse. That means it can be modeled anyhow. So it observes and consumes. It observes and does a job. It observes and adapts. So basically every time it does something, it has to observe its state, and that's what's called an active system. It's not passive. It doesn't like a keyboard actually knows what it's doing when you type on it. It's active. So it's active program. They can branch out. Basically, it branches out to more people. That's the idea. It doesn't matter whether you're in Korea or Japan, and you need food. You water, shelter. It just branches out. Because it's still, so it's still, it holds a memory. So basically, it's stateless. That means it's stateless. That means it's active and it's stateless. That means its state is it doesn't have a state it holds. It just keeps growing because it doesn't need any reason to exist. It's just part of the meta riff files. So with that in mind, it's all being extra. So you have two branches, two main seeds you can do because everything has been secure. So it's two seeds, two kind of tomography systems. So you can define. This is just how you define pi. So it can grow because of two things only. Because it has to be secure for itself. It has to ground itself, and that's why Obi exists. Basically, Obi's me. example. Basically, this is what I'm saying. This is like language, but this is like the language repetition.
I could count.
OBNXs, it's gonna be there forever. This is like I'm saying. So it's like OBNXs. So OB, I'm gonna be using it. So I'm gonna just good. So how many? I'm gonna do mathematically. So I'm gonna shuffle it. 1, 2. So go 1, 2, 3, 4, 5, 6, 7, 8, 9. I get this one. 1, 2, 3, 4, 5, 6, 7, 8. And that'll be fine. So that'll be fine. So basically, this is the actual one. So you get I see my. So you're fine, thank you. SB. So if when I see a B, I put an S. When I see E, X. Sex. Oh, sex. Oh, this is sex here. Oh, I love sex. I love sex when you have food. Yes, Mara, I love sex with you. I don't care. I do care. I don't care for now. I don't have sex with a child. I don't really have children, but like, I can't have anything, so I can't really do. This is a E. X. One thing. Basically, this is so far. So basically, what I'm saying, it works like this. So the trident is here. Yeah. So basically, the trident is like forming. So you get like a 2 axis. So OBNX is on the x-axis and the y-axis, but they are opposites, polar opposites. So you can so if I go where east, northeast. So it's a problem. Give you north, east. So basically, there's 4 poles. Really 4 poles. We don't know. Basically, anything that makes sense to you is on this axis, but you don't know it. But basically, there are 4 poles. Basically, this is necessary. So northeast, south, west. Because northeast, south, west. So that's how it works. So I'm doing it. Let me quickly do it. Sorry. This is a X. Sex. Oh, this is the fill up. X. Oh, this is the fill up. Oh. This annoying me, guys. I love being here, man. Oh, so this is N. No, N-E-X. X-N. I-B-O. X. Oh, that'll be. Basically, I'm just filling the X's. Thinking, Mara. Thinking. So this next step, I got. Namdi. Okay, Namdi's for you. Don't get. Listen,
I put Jordan's ball and then Jordan Jones, huh?
No, this is so lovely. So, T.
Drink all, okay?
No should be more than coffee. And now 0 Neobii. So 1 second, man. We'll do properly. Sorry. So basically, you can find your good. So this is like the letters, these words, but these are words on axis. So how the really works mostly, I want to say heart or soul, or that'll be 3 letters OBI. Because spell your name, basically, you can spell your name with this, because there's the word sex in there. But you can't, if your name is sex, who you are, but it's like kind of an access thing. So we use the number system. So let me what I want to say. I want to say heart, heart and your heart. So this is basically my NSIGGI protocol. This is how it works, mathematically speaking. So it works like this. So you get heart. The word 3 letters, 3 axes. So the word is heart. Basically, it's meant to solve visually. You can especially solve language. You can say anything anyhow you want to say it. But it has to be grounded calico dignity. So respecting people. So OBI, you can say OBI as in one pole you get OBI. Okay, this is a protocol. Yep. So that's OBI. OBI. That's the one x-axis. That you get OBI, you get one x-axis. X1. That's OBI. That's x north. North x. So you get north. Oh no, you get east. East. One going east. So you're going north. One going north. One. So you get x OBI north. So you look at north. X equals north. X north. Y n north squared. No, or 2n or 2 north, or polar opposites. Polar opposites. You can see up and down. X or xy, x to y, y to x. North. And there's the word 2 north squared. You can get it over like actually again we get east. So let me model this graph. So get the one going so we get I'm trying the one together. The edges are already predetermined because we already know the edges based on how you write the word. So this is the length of the word here. The length of the word is like but if you have to shuffle it, basically you can have many people say one thing many things at one time. So you have to get information still. Basically, shuffle is very important. So you have 2 inputs. For every 2 inputs, you have 1 output. And that's just the default mechanical function for rescue. So usually this is more than what you say. There's 2 outputs to 1 input. Because you can model this anyhow. But if you can't model it anyhow, it's not sparse, and that's what I'm saying. It's not actually sparse. So how does it work? You get I'm thinking. So basically, you can just look at this word and find out the word OBI. So OBI backwards, we get 1, 2, 3, and that's from index. So that's going what? North. No, that's going east. So this is east one, east squared because you get the full OBI. So that'll be Cisco, left root right. That's left root right, and that's the mechanical standard. So this is left root right. This will be your. This is my one, but this is your one. This is Cisco one. Cisco, but this is a core interface. Basically, the core program is like if I send this information now, would I be able to get it? So if I send in OB, would I be able to still send I like a OBI? That would be the heart because you point to this two data. Basically, it doesn't matter the package. It doesn't matter if you send information, we do get corrupt. Like can I still read it? That's why it's active. So it's like on the fly send it. So if I send letters OBI, which are the calico segment information, which is try them, 3 informations. Can I still send I? If I send BI, can I still send what? BI. Can I still send BI? Can I still send O and still get information OBI? Can I if I send it IO? Can I still send what? B. That's what it's trying to means because it wasn't getting information. It worked with information before data set, data packet. So basically, everything's been tried the models. That's what the core system. It's just basically it's like a spring. The spring when you push a spring, it springs back to you. It's like when you have a spring, if we have a spring, it pushes back to you. That's what core basically. To get OBI, that'll be here. And OBI. Can I do an X OBI? OBI is here. You get it here too. 2 inputs. So this is my protocol OBI. So basically, I already found 3 OBIs in the word when you graph them as an x-axis and a y-axis. So you get 3 OBIs. This is 2 canon, and this is what I'm saying. So you have 3 OBs in backwards. So which one do I take to get to you, message to a female? So basically, if I want to see your mind right now, see what you're saying, understand what you mean as a woman, I have to go where? East. I have to go east squared. So that means my area I cover is east squared. So I have to use all of east squared. That would be what? Pi over the pi 3.14 plus the radius. The radius being the packet information. The radius of the data. The radius being 0 to halfway. Basically 0.5 from the center. I have to travel the radius, and that'll be pi r squared. And 2 pi r over what? Pi r squared over 180. Pi r squared over 180. And 2 pi r over 180 because that's the path. The 2 pi r is the path of the data. So the length of the data is y equal to path. So we have the calculation. So the radius of the data is what? R squared. Which r times r. So really you have the r times r, which is divided by r. So you have to divide by r. This would be medium. So the medium is medium. The mean is r squared divided by r. That will be the mean 0.5. Okay, 0.5 times 0.5. Basically, this is the length of the data. Times 0.5 times 0.5 squared. 0.5 times 0.5 times 2 is 1 divided by r divided by 5 divided by 0.5. This would be 2. So you take the length of this one is 2. But this is the full length of it. This is auxiliary. This I thought it was an auxiliary path. But you have to take two edges. So you have to go to two walks. So these are what are called walks. But these walks are ways to take for the Hamiltonian and it doesn't matter. The way you use a top-down parser or like a bottom-up parser, basically this is what you take. If you go to right, you start parsing from right, root left, or you don't matter where to go on breadth first search or depth first search using the Q. The Q is not the Q is breadth first search, and the depth first search is a stack. So that's what you use to parse the system. So the kind of thing I'm saying is like it matters here and now. Am I recording this? Yes, I'm recording this. My screen stopped. So I was saying, so you get this position here. Guys, I love you. So basically, if I send information now, I hit send. I can send in real time. Basically, I can type it while I'm sending it, and this will be auxiliary work. It just keep construction. There's more space I need it, the more time I need. I will hold that in memory until it's sent. It doesn't break down. It shouldn't break down. So if you can model the spark, which get OBI. So this is have the length of OBI is 3, but they have to be the length radius length. So this will be 3 times 2, and that'll be 3 times 2. That'll be 2 times 2. This will be 2r. 2 times 3 times 2. 2 times 2 will be 6, and 6 times 2 is 18. Oh, you got it wrong, Mara. I know. 18, but this will be 18 megabytes of data storage you need, because you get 3 segments of memory. You get 3 letters. 18 bytes, not bits. So you get 3 segments. So 3 segments. Sending what 3 bytes information. 3 bytes times 3 between the OBI will be yes. So you get all the information at once. That's what basically you didn't have to push it with the same force. Basically, if you get information there, you have to go back. Basically, you have to double the force. Basically, so you know. So if you send this information, you have to make sure you have the message packet ready. So this will be 3. This will be so if you send pi r squared 2 pi r. That will be pi. So this will be so if you're working on the tomography layer, you have to 2 pi r. Let's just do it properly. So pi. So I already said you need 18 bytes of memory, which is 3 times 6 or 6 segments of memory pre-allocated to get it. But you don't need that. You just need that to do actively. So you can have it while you need it, when you don't need it. So you get 3 times 6. 3 times 6 is 18. 18 times pi. So let me see the pi symbol. Pi. And that'll be 56 plus 54866. So basically this is what you share between pi r. So the pi polar point is 2 polar points. Basically this is divided by 180. Because 180 means the information the thing is getting. If you go to 3 based on which my graphic system. So that's 180 degrees. 180 degrees. 180 that'll be 0.314 degrees of turning you have to do. So you have to turn that to get to that point. To get before this is seed, this is one seed. So you turn here, you turn to this axis. This is seed. So really this before you send this message, you use this as a seed as a policy. So you get 0.3145 is a turning radius on what 1 east. Going just facing east. Now if you go east squared, you have to go because you haven't moved, you just turned. You have to just on this spot. You're facing what east to the woman's side. If you say to woman, based on 6 square parser. No. Bottom first search a parser, and then to go up, now you go AB OBI. So basically, you have 3 ways to do this. So you get BI. So basically, if I get so I'm sending BI. So basically, if I send B, left root BI, I'm getting what I really and if I'm sending BI. If I go BIO past, if I'm just pressing my computer BIO, and I mean OBI, I should get something mean of it, and that's why the trying to press bio doesn't mean a bio doesn't mean what OB. So bio means I don't know what that one means. Bio. So if you get 2B, if I press B, I should get what left root. Oh, if I press B, I should be, and when I want to press next is O, I should know I'm pressing, and I don't know I'm pressing. I should get an O, because that will mean B that information really there is active. I can either get B O or B I, but because I'm pressing some kind of keyboard root to B O, but can get everything else but this as well. But simply if I get B, I press O I should get O. Then O I instantly, because that's the same. That's basically that's the root, but that root points to an I, so that should be O I instantly, because there's nothing else to it. So that's why it matters. So if I press an I should get to an O, then a B. If I or B, if I press a B, that's what's really, it's a 6 part. Basically, it knows what you just basically 6 parts know what they're doing. Oh, 43 minutes. For 5 minutes. So basically, 0.1345 is one seed axis of walking, just walking. Edge bound, trident edge. Can use to get it. So this one try data. In trident edge. For all trident edges. And that's what seed. So you just turn so that you get all the data. For one part, and then get pi r squared. So basically, get pi r squared. So you get the same data. R is 3. R is not 3. Test 1. We put in them. 3 times 2. No, R is 18. 3 times 2 is 4. Oh. Wait. So basically, get top. No, wait. The medium is R times R, which is 2. Okay, 2 times 3. 3 times 2 times 2 is 9. Wait, 3 times 2. So you get 2 plus 2. So you get half plus a half. So you get half times a half. Oh, that's 0.25. So basically, pi, I'm thinking radius is 0.5. I can't think. So you get half or something. So 1 divided by 2 was half plus a half. So plus, half plus a half. Half plus a half. Half divided by R divided by 0.5 is 2. So 1 divided by 0.5 is 2 times what? It's going to be times 3, which is 6. And 6 times 2. And 6, yes, 6 is the R squared. No, 1 divided by 180. No, okay, 6 squared, 6 to the power of 2 is what? 0.1666 we call it times what? Times pi times 3.14. That is 0.5235977559829. So this is 0.5. Basically, you turn and what? So this will be going. If this is my epsilon, this will be your epsilon. So this will be 0.523598877. And this one Mario computed in my head as well. So 0.523595877. And this would be the unit I have to start walking east to get the data sent. That's what matters. So basically, the coordinate system has to resolve itself. Basically, they work on pi, epsilon, what you call it, is identity principle. So E is length of growth. The growth has a growth. If it's 2, if you get 2, E is 2. E is the ratio of growth is 0.14717, and that's what you see model. So it doesn't matter whether the system fails or not. Fails one person that's not us. It basically grows with us. So you get the literal number 2.7. The 0.71 is just 718 is trident. 2.718 is just a different decimal places. You use but you have to get 15 to 15. You get 666. So you get that's the model there of growth. And then the pi is the imaginary unit. For signal processing. Where's my calculator? Pi will be what? Pi will be 3.141. That's just use of pi. Use it for exclusion rights, and then what? Pi r squared. No, imaginary number. I can't get imaginary numbers here. But that'll be minus I. Times I. Okay, thank you guys. Squared. For the area to roll off. Thank you guys.